In WarpPLS, we have 5 steps, and you need to follow these 5 steps one by one. Right? Here there are some information about WarpPLS and how you can, what is these 5 steps, and what's the, actually the WarpPLS was developed by Professor Ned Koch in 2009, WarpPLS 1, and improved in different versions, and now we have WarpPLS-SEM that was released on in 2019. So this is the latest version of WarpPLS, WarpPLS 7.0. Okay, so step 1, these 5 steps are very simple steps to create your framework. When you click on step 1, you will transfer to this page, and here you can open project file. If you have the file that we create in WarpPLS is with the PRG or project extension. And the difference with the first difference between WarpPLS and SmartPLS is when you create a PRG or project file, all your information, including data set, is in this project file, and you can very easily email your file to somebody and copy and paste your project file, and there is no any other attachment for this file. All information is this inside this project file, and this project file is very small file. So in this small file you have all information. So if you already created a project or you have a project, you can open it. But if you want to create a new project, a new file, a new framework, you need to click on create. So we click on create. Where we want to create, okay, we go to our folder, for example, quantitative, yeah, here. I want to create a quantitative research method project, right? So this is the name of project, and you can see the extension of project is PRJ, right? So save it, click on OK. So step 1 is done. Second step, then when you create your model, you can go to step 2. And actually you can see a step 2. Step 2 will be activated. So before that, you cannot click on step 2. Okay, now click on step 2. In step 2, you can, in this step, we need to read our file, data set. We can read from file, or we can copy from an Excel file and actually read from clipboard. So actually we copy and paste in our framework. So it's possible in WarpPLS that don't use a whole data set, just copy part of data set and some variable that we need, and here we can read from clipboard. But we read from file. Another difference between WarpPLS and SmartPLS is WarpPLS is able to read XLS or XLSX file So can read Excel file, also can read the tab delimited file or comma delimited file. You remember in the Smart PLS only we can read CSV or comma delimited file. But here we can use 4 different types of files. Okay, so read from file, go to assignment. Here we can change to all file. Okay, for example, this one. This data set is XLS, right? But no need to change to CSV. We can use directly Excel file. So click on this one and open. Now you can see here your data file. This is your data file. Don't click anything. Generate MATLAB code, don't click it. Just click on next. And finish. So here you have your data set. Here you can check your data set. If there are some problem in your data set, if you have so here you can actually screen your data set, right? The first row is name of variable, and actually other rows are your data. So if your data set is okay, just click on yes. So now you pass second step. And in second step, you read your data file. So you can go to step 3. Next step. Now you are able to go to step 3. When you click on step 3, at step 3, there are some pre-processed data. Actually do something in your data set. For example, if you have missing value, replace missing value here. But missing value here means empty cell. Empty cell. So in this step, some processing happen in your data. For example, here you can see checking for a missing value and replace missing value using mean replacement. Later I will show you, you can change the method of missing value imputation. So do some other checking for your data, and when you click on OK, you can go for next step. So now your data is one important step that happened here is here you can see standardized data. So in this step, software change your data to standardized data. Right? Change all data to a standardized data. So if your data looks correct, can click on yes. So in this 3 step, you create your file, project file, read your data, and standardize your data and do some processing like missing value imputation or replacement. Then you can go to a step 4. When you click on step 4, define SEM model. When you click define SEM model, you can go to this page. You can go to this interface. So here you can create your framework. You can create your framework. You have some option in this menu bar. Model option, latent variable option. So here you can create latent variable, edit, delete, or move latent variable. Direct link option, moderating link, and help. Here you can get help for overall, you can get user manual here, or you can get help for any of these parts that you need. Okay, so we start with latent variable option because the first thing is to create latent variable. So we need to click on create latent variable and click on this white window. When you click on this white window, you will come to this page. Here you can define the name of your latent variable. Okay, first is community attachment. So the name of variable is community attachment. Here you can see your indicator. All indicators are here. So for community attachment, you have 6 variables, 6 items, right? 6 items or 6 indicators. Click on add. When you click on add, this indicator will transfer to this box in left side. So you add indicator from this box to this box, left side. If you want to remove one indicator, for example, wrongly you transfer one indicator. Okay, I transfer EA3, but I don't want. Just click on EA3 and remove it. We'll return back to this box. Okay, so, and here we can select reflective or formative type of construct. If construct is reflective, so you can stick to this keep default. And if you want to change to formative, just click on formative. But I keep reflective one because community attachment is reflective construct. Okay, so when you transfer this one, just click on save. So we have the first latent variable here. You need to repeat steps, same steps for other variable. Second one is economic gain. So economic gain has 3 indicators. Say next one is community environmental attitude. Environmental attitude is 1, 2, 3. Say and involvement 1, 2, 3, 4. Involvement has 4 indicators. Just say. So you have you can click on construct and move anywhere you want. Okay. And we need to create also support. Our dependent variable is, for example, support. Okay. support. You have 7 items for support. Click. So now we have 4 independent variable or the exogenous variable and 1 dependent variable. Now we need to click, we need to create link between these variables. So click on direct link option. Create link. Create link. You need to click on beginning and end of arrow. Create beginning, end, create beginning, end. So now you have your framework, right? 4 variables, influence on support. When you create your framework, here in first option, model option, you need to save model and close this part. So you can complete step 4. Save model and close. SEM model created successfully. Press OK to continue. Okay. This explains the individual inner model. Algorithm setting have been set as a default inner model and outer model. So just click on OK to continue. No need to change anything. So now you created your framework, your model. Then you can go to a step 5. Click on step 5. And in step 5, only you need to click on perform SEM analysis. Click. Now you have the result. Here you can see another difference between the Smart PLS and WarpPLS. In a Smart PLS, when we perform PLS algorithm, we can get path coefficient, we can get R square, and we can get criteria for assessment of measurement model. But in WarpPLS, in one click, you can get all result for assessment of measurement model and structural model, and also result of bootstrapping. So no need to perform PLS algorithm separately and then bootstrapping. By performing SEM, you can get the result. So here you have the result of your model, but you need detailed result for assessment of measurement model and assessment of a structural model, right? Okay. If you go to view, click on view, you can see different results for and different criteria that you can use for assessment of measurement model and a structural model. Here in this framework, all our constructs are reflective, right? So for reflective construct, first step is assessment of indicator reliability. So we need to check loading, outer loading, right? We need to check outer loading. Okay, before going to this one, I already shared this paper, a few papers. These 2 papers for as samples for reporting result of PLS, result of measurements model and structural model. So you can download these two papers from your Times profile in the dataset folder. So you can follow steps in these two papers to report measurement model and structural model. In these two papers, in this paper we use WarpPLS, but in this paper we use Smart PLS. But the steps for reporting result and assessment of measurement model and structural model are very similar, right? So first step for reflective construct is creating this table, assessment of the result of measurement model. And for measurement model, we have to report loading. We have to report CR, current batches alpha, or rho A for construct reliability. We have to report AVE for convergence validity. And then we need to report discriminant validity using Fornell-Larker criterion and HTMT criterion, right? So this is same when you use WarpPLS and Smart PLS. Here you can see the steps. This is, here we apply Smart PLS, okay? Okay, you can see CR, current batches alpha, AVE, outer loading. Here we reported mean value and standard deviation because the reviewer asked us to report this one, but actually this is not necessary for reporting measurement model, right? And actually here, I remember for this paper, to reduce number of tables, they asked us to remove table for assessment of discriminant validity. But we reported in the text for the Larker and HTMT, right? So the steps are same. So first things for assessment of measurement model is to check loading. Where we can check loading? Here we have indicator loading and cross-loading option. But WarpPLS provide different values for loading using different types of rotation. So here you have very varied data, varied result for loading. But the best choice is using first one. Combine loading and cross-loading. So when you click on combine loading and cross-loading, here you can see the result of loading and cross-loading. Loading of items of each construct are in bracket, are in parentheses. So here the loading is 0.763, 0.848, 0.805 for community attachment indicators. For economic gain, here you can see this is for economic gain, right? This is for community attachment. This one, environmental attitude. These three are for environmental attitude. For involvement, this is for involvement, right? And also here you can see type of your indicator, reflective, standard error, and p-value for indicators. Actually, no need to report significance of indicators, but here you can you have access to p-value of indicators. P-value of loading, P-value of loading of indicators. So here you can see the result of loading and also cross-loading. Cross-loading is similar to factor analysis. CA1 load on community attachment construct 0.763, but also load on other variables. And here you can see loading of CA1 on other construct. These called cross-loading. The loading on a construct other than main construct. It's associated construct, right? So in this table, you can see the result of loading. You can check and see if there is any problematic loading and you want to delete it or no. Here you can see all loading are higher than 0.5. Most of them are higher than 0.7. And only one is lower than 0.7. So for this one, we need to look at CR and AVE. And if CR and AVE are higher than 0.7 and 5 respectively, so we don't need to delete this item, right? So this is for loading. What's the second criteria for assessment of reflective construct? Is construct reliability. Construct reliability. So view latent variable coefficients. If you click on this one, you can get very huge information here. Here you have composite reliability, current batches alpha for all construct, so and AVE. So AVE are higher than 0.7 for higher than 0.5 for all construct, right? AVE for 5 construct or higher than 0.7, 0.5. And CR and alpha should be higher than 0.7. So these two are higher than 0.7 also for all construct. So here you can see the result of construct reliability and convergent validity, right? Here also we can see R square. Later we will back to this one, R square, Q square, and many different criteria or methods for assessment of normality, multivariate normality. This one is not available in other software. In other software, also in SPSS, we can actually calculate univariate normality or normality for indicators. But after we need to create a construct, and after creating a score of construct, we can actually calculate normality of construct. But here we can see the normality of construct, these 5 constructs based on different methods, skewness and kurtosis, and these methods. These methods are different methods. For example, here based on unimodel RSC community attachment is normal, but based on normal JB or normal RJB is not normal. So Actually, these methods apply different algorithms and approaches to check the normality. Here also you can see the histogram. So this is the histogram for community attachment. This is for economic gain. So you can see different criteria for assessment of normality. But we need this criteria. If you want to report multivariate normality, you can use one of these methods. Which method, which approach we choose depends on your area. In some area like finance and economics, they prefer some specific types of, some specific method for checking the normality, right? But we can still apply skewness and cortices for these constructs, right? So based on skewness and cortices, we can interpret normality of construct. Okay, so we can get the result of construct reliability and convergent validity from here, right? Next criteria for assessment of measurement model is discriminant validity. Discriminant validity. Discriminant validity we can get from two different parts. We can get from correlation among latent variables. If you click on this option, view correlation among latent variables, you can see square root of AVE of each construct within bracket. For example, this one, this is square root of AVE of community attachment. And also you can see correlation between community attachment and other construct. So this is based on Fornell-Larker criterion. Fornell-Larker criterion. So you can see the result of Fornell-Larker criterion for assessment of discriminant validity from this table. If you want to see the result of HTMT, you need to go to other part. Close this one. When you close the view, you can come to Explore. Explore was added in version 6 and 7 of WarpPLS and actually included many features in this Explore. Very advanced features like full latent growth analysis or multi-group analysis or some other features. But in Explore part, you can explore additional coefficient and indices. If you click on this one, here you have a few options. Discriminant validity, you can get the extended set from here. So here you can see the result of Fornell-Larker criterion. You can see cross-loading. You can see full collinearity. Full collinearity is another criterion that is provided in WarpPLS, and especially when we have formative construct, is useful for assessment of discriminant validity for formative construct. And HTMT ratio. Here you can get HTMT ratio. So this is the HTMT result for assessment of discriminant validity for reflective construct. So here you have HTMT and also Fornell-Larker criteria. So this is for assessment of discriminant validity. So far we got the result of the criteria for assessment of a structural model. We check loading, we check CR and alpha, AVE for convergent validity, and the Fornell-Larker criterion, and HTMT for discriminant validity, right? If you click on reliability extended set, here also you can get row A. This PLSC reliability is row A. So here you can get also row A. Row A, this is row A. And also WarpPLS provide another two criterion, factor reliability and true composite reliability. So these two criterion are developed by this software and developer of this software. But this one is row A. First one is row A. Row A. So you can get the result of alpha, CR, and row A for assessment of construct reliability, and also discriminant validity for using HTMT and Fornell-Larker criteria. Right? So based on this result, you can get, you can assess measurement model. For a structural model, we need to report R square. We need to report Q square for predictive relevance. We need to assess significance of path coefficient. And we need to check F square or effect size for each construct. And effect size is the share of or portion of R square from each construct, right? If you click on view again, okay, here you can see R square. This is R square. And also if you go to latent variable coefficient, here you can see R square and adjusted R square. So here you have R square. Here you have Q square. So this is Q squared. And Q square should be higher than 0. Should be higher than 0 for acceptable predictive capability or predictive relevance of model. Okay, so this is R square and Q square. And you can get path coefficient, significance of path coefficient, and standard error and effect size for path coefficient from these two options. Okay, if you click on path coefficient, this is path coefficient. This is p-value for path coefficient. So all path coefficient are significant. All your hypotheses are significant, but also you need to check the sign. All are positive. So if you hypothesize positive relationship based on these p-value, you can accept this hypothesis. And next option is standard error and effect size for each path coefficient. So this is effect size for the effect of CA on support. This is for effect of economic gain on support, environmental attitude on support, and involvement on support. So here also you can get effects, right? So this is the result of F square. So you can check all these results in this view part. If you prefer to transfer data and read your data in Excel file and see this result in Excel file, so it's possible. You can save all estimated parameters. All estimated parameters. First option. Okay. Results. For example, here result QRA project. Save. Okay. If you go to your here, you can see the result of your analysis, but the result is in tab delimited file, tab delimited extension. If you want to change to Excel file, you can read in Excel file. You can open in Excel file and save in Excel file. Okay. For example, if you have I want to read in Excel file, so click on File, Open from here. I have here. Okay, this is the file that I have, result QRA project. So click on this one and open. Next, finish. So you have result here. So you can save the result in Excel format. Save. But you can change to, for example, Excel, and you can save the result. So now you have the result in Excel format. So you can click and see the result in Excel format. And here you have all results that you need. Pad coefficient, standard error, effect size, combined loading. You can use for first step of assessment of measurement model. You have another type of loading, but you don't need this result. Indicator weight for formative construct. If some of your construct are formative, you can get weight from here, and p-value, significance, and VIF, variance inflation factor, for assessment of formative construct. Here you have R square, adjusted R square, composite reliability, alpha, AVE, QS square, some tests for normality, and all information that you need, you can get from this Excel file, this result file. Okay. So based on this, you can assess measurement model and the structural model in WarpPLS.